Hi dear students, let's see this question that was asked in KVPY 2020 SX Part 2 Physics paper. This was one of the very good questions, and actually let me tell you, this whole Part 2 of KVPY 2020 SX, like most of the questions were really awesome. So this was one such question, really good. So in this question, what is happening? It is said that sun rises from the east at 6 a.m. and it will set in the west at 6 p.m. So basically 12 hours is what sun is going to take to rotate by an angle of 180 degree. Let us say this is the earth, or we can say this is the center about which the sun will be rotating like this. So sun will start from here and it will be follow this type of trajectory. Let me show you in this in the next slide. So if this we can say is earth, or some a point on earth, so sun will be following this type of trajectory on a circular path, and so this is east and this is west. Okay, so it will take 12 hours to go from east to west. So at 6 a.m. sun is here, at 6 p.m. sun is here, so naturally at 12 p.m. sun will be at the top most point, right? Now it is said that there's a camera which has been installed like this. At a certain moment, what happens? The intensity recorded by the camera is lowest, and the light ray is coming from sun, reflects from the surface of the water, whose refractive index has been given as 4 by 3 and 1.33 actually, which we can write 4 by 3 approximately. So this will go back to the camera after reflection. Okay, so it is said that intensity intensity of the light is minimum. My bad. Sorry, intensity of the light is minimum. Okay, so if the intensity of the light is minimum here, so we can say that uh, so this angle we have to find the time at which this intensity will be minimum, right? So we have to find the time at which this intensity will be minimum. Okay, now first thing is that we need to find this angle. Okay, so the logic is that this angle should be Brewster's angle. Okay, so basically tan theta should be is equals to mu, or which we can say refractive index of water, which is 4 by 3. Okay, so basically we can say that this angle should be equals to Brewster angle. Now why this angle should be equals to Brewster angle? The reason is that if you know Brewster's law, what is said in Brewster's law? Suppose this is like this medium is of refractive index mu. Okay, let me show this in next slide here. So this is refractive index mu and this is air. Okay, suppose light is coming like this. Okay, so we know that a part of the light will be reflected and the remaining part will be refracted. Okay, this part will be refracted. Now in this reflected part, the electric field is generally, if this is any general angle, that means this angle is any angle, 30 degree, 20 degree, whatsoever. So electric field in the reflected light will have in general two components. Okay, uh, such that the net electric field will always be perpendicular to this reflected ray, but the overall electric field will have two components, which we can resolve, one like this and one perpendicular to the screen. Okay, so which I am showing by dot. So this dot component is perpendicular to the screen and one component will be like this, perpendicular to the reflected light. So overall also electric field you can see will be perpendicular to this light ray. Okay, now by Brewster's law, we can say that if this angle becomes tan inverse mu, that means Brewster's angle, then this like electric field becomes totally perpendicular. One of the component is lost and electric field is totally polarized. That means the intensity of the light will be greatly reduced because one component will be totally lost and only one component will remain. Hence, we can say that electric field will become totally polarized. So this is the Brewster's law, right? So we can say that if you want intensity to be minimum, then the light should be totally polarized, because in that case the loss of the intensity will be maximum, and we can say that in such a case light should be incident at the Brewster's angle. So I hope you are able to understand why should light be incident on a Brewster's angle, right? So now it's very easy to say that in this case theta will be equals to 53 degrees. So Brewster's angle is 53 degree. Okay. So now we have to just find how much time will sun take to rotate till like from here to here. Now from here till topmost point. So let's go on this slide. Okay. So we know that sun has come somewhere over here and this angle is 53 degrees. Okay. So from here to here, sun is going to take 6 hours. So like this is the from here to here, sun is going to take 6 hours. Okay. To rotate 53-degree more, we can say that 53 upon 90, because 53 upon like 53 degree, we have to find the time taken by sun to rotate 53 degree. So 90 डिग्री रोटेट होने में सन को लगेंगे 6 आवर्स. ओके सो 53 डिग्री रोटेट होने में 53 बाई 90 इंटू 6 आवर्स, तो उसको मिनट में कन्वर्ट कर सकते हैं. सो दिस इज 6 इंटू 60 मिनट्स इंटू 53 बाई 90. 6 वन जा 6, 15 जा 15 वन जा 15 4 जा. ओके सो दिस बिकम्स 212 minutes. 212 minutes. So which is nothing but 3 hours 32 minutes. 3 hours 32 minutes. Hence, after 12 p.m. it is going to take 3 hours 32 minutes more. Hence, it will be 3 p.m. and 32 minutes. That means 3.32. I mean 3.32 p.m. That means 3 hours 32 minutes. 3.32 p.m. means 3 hours 32 minutes. So I hope you would have understood this question. I hope this was clear to you and you would have also enjoyed the solution, that this was a very good question. That's it. Thank you.